I'm Lavendra De Silva. I'm a research professor in the Cambridge University Engineering Department and a director on the Digital Roads project. Digital Roads is starting to see some useful and exciting outputs generated so far. For example, from the academic side, we're seeing about 60 research publications come out of the program. From the industrial side, we've got a spin-off company, Didymai, whose sole purpose is to build digital twins for the built environment. We've also started to build our own simulation platform, which is able to simulate not just autonomous vehicles, but also our own in-house designed autonomous maintenance plant. And the purpose of this plant is to fix road defects early enough before they get much worse. From the smart materials side, we've had materials that are able to withstand environmental changes much more robustly than traditional materials and cope much better with robotic extrusion. The data science team have built tools that are able to, for example, generate treatment plans that are able to treat road issues based on historical and current information about the status of the road network. And all of this comes together in the form of a digital twin. We've got a prototype already built based on about a 40-kilometer segment of the road network, which we've created a 3D model out of. And this digital twin is slowly starting to see dynamic data coming in from various sensors. Going forward, we'd really like to focus on the impact theme in the project, and we'd like to see these outputs generate useful and beneficial outcomes for our industrial partners.
I'm Dr. Svetlana Besklubova, Assistant Research Professor at the University of Cambridge. We are developing a comprehensive digital twin that leverages a foundation data model and reference data library to enhance interoperability and data security. By collaborating with domain experts, we ensure our solutions are scalable and future-proof. We also provide solutions for the continuous maintenance of the digital twin by implementing real-time data integration from detected objects and properties, facilitating proactive maintenance and enhancing overall management practices.
I'm Dr. Lilia Patsiluika. I'm Industrial Research Fellow from Costain and I'm based at University of Cambridge. Digital twins are complex systems made of multiple puzzle pieces, including updatable geometrical models, geographical databases, data science outputs, and insights. All these elements integrate in high-fidelity virtual environments and advanced interfaces. We aim to develop systems that provide fast feedback to road maintenance assessment and enhance decision-making support.
I am Dr. Alix Marie-Davigneau, and I am the Industrial Research Fellow in Data Science at Costain, working with the University of Cambridge. Data science is at the core of our project, from recognizing road damage to diagnosing its causes and automating maintenance decisions. We are leveraging statistical and AI-based methods to optimize asset management. One of our applications is predictive modeling, which enables us to anticipate road deterioration and take preventative action. To work towards predictive modeling, we have been developing a comprehensive dataset combining defect counts with factors such as traffic flow, pavement age or material, and environmental factors. The aim is to predict the probability of defects appearing under various circumstances via spatial modeling. This will help in reducing long-term costs and improving safety and efficiency.
My name is Stephen Green. I am a Senior Research Associate for the Department of Engineering here at the University of Cambridge. Here in the Data Science Division, we're currently developing an automated decision support tool that translates the real-world data obtained from road sections all over the country to their appropriate treatment plan. Our system observes defects and the severity of their condition and provides appropriate treatment plans based on what caused the damage along with relevant repair strategies. The optimum version of this is then decided based on how long they will last for and how much they will cost to implement. This tool will be supported by existing maintenance data processed with the help of machine learning and distributed to researchers across the field.
My name is Damien Palin. I am a Senior Research Associate here at the University of Cambridge. To prevent small-scale damage escalating into more dangerous and costly damage, you need materials that are both more durable and potentially handleable by autonomous systems. Here at the University of Cambridge, we are developing a series of advanced repair materials for pavements. These include fiber-reinforced cementitious repair materials that are both twice as tough as standard materials, but also are handleable by our robotic systems.
I'm Jerry Xu. I'm the Senior Research Associate in Automation and Robotics at the University of Cambridge. To allow the optimal robotic pavement crack repair, we developed a physics-based, multi-level robotic crack repair simulation framework. This includes repair material simulation, crack filling process simulation, and full-scale robotic task simulation to predict the operation performance towards highly accurate and fast repair.
I'm Dr. Richard Envo, Industrial Research Fellow at Costain, working for Cambridge University. We are taking road maintenance to the next level with cutting-edge autonomous technology. We are simulating smart repair vehicle with a single operator capable of securing the environment, scanning road surface, applying innovative repair material, and updating the digital twins. Our innovation is setting a new benchmark in road repair efficiency and durability.